Hey guys, Mr. T here, just doing another video on reflection. It's a transformation where the points of an object are on the opposite side of a given mirror line. So when you look in a mirror, you see your reflection. Same applies in maths. You're given a mirror line and you're reflecting an object in that mirror line. It goes to the opposite side. And one key point to that is the points of the object are an equal distance from the mirror line as the points of the object were. So when you draw your image on the other side of the mirror line, it's going to be the same distance away from the mirror line as the object was to start off with to form the image. It's a bit easier to visualize that rather than just talking about it. So you've got this triangle, which is the object. On this side, A, B, and C. You've got the mirror line, which is one unit, one grid square to the right of that triangle, to the right of side A, B. And so if I mirrored that, you're going to have the triangle facing the opposite direction on the other side of the mirror line. So what can we see about that? A in the object was 1 unit left of the mirror line. Well, A dash, the A in the image, is 1 unit right of the mirror line. Okay? B in the image is going to be 1 unit right of the mirror line. And C, it used to be 4 units left of the mirror line. Well, now C in the image is 4 units right of the mirror line. So you can see that it's just on the opposite side. The points in the image are on the opposite side of the mirror line, but they're still the same distance. Okay? Now you've got a special case here of reflection. That mirror line in the previous diagram was just anywhere. It was just based on the grid dots. It was just a vertical line there. But if you put things on a Cartesian plane, if you do reflections, and most of your questions are going to be doing, well, some of your questions are going to be doing reflections in a Cartesian plane, the points have certain coordinates. And you can reflect in the x or the y axis. Now, if you're reflecting in the x or the y axis, specific things happen to the coordinates, and sometimes this can make it easier to do the reflection. Instead of just visually doing it and looking and just visually placing the points, you can just decide where the points need to go based on the coordinates. So the first example I'll do is reflection in the y-axis. Here I've got a Cartesian plane. You've got a mirror line along the y-axis, and I want to reflect the point A is -3, 1. If something is reflected in the y-axis, for every point in the object, the coordinates in the reflection have a negative version of the x-coordinate, but the same y-coordinate. So in other words, if the image was A, x, y, in this case A was -3, 1, the coordinates of the image are going to be negative whatever the x was, and the same y. So visually, I can see if the mirror line is here, the point A in the object was 1 up and 3 to the left. Well, if I'm reflecting the y-axis, it's going to be 1 up and 3 to the right. That's the image point. But what are its coordinates? Well, you can see it's 3 across and 1 up. So 3 and 1. And you can see that that follows the rule here, that if you reflect in the y-axis on a Cartesian plane, the x-coordinate is going to be a negative version of what it used to be. It was already negative, so negative of negative is a positive, and the y-coordinate is going to remain the same. So negative x-coordinate, same y-coordinate. That's what happened. That's what happens if you reflect in the y-axis. Now, if I reflect in the x-axis, you see here the mirror line is along the x-axis. So now it's going to go up and down, not left and right. So the point I'm trying to reflect is -2, 3. So if something's reflected in the x-axis, for each point in the object, the coordinates in the reflection have the same x-coordinate. So before, it was the negative x-coordinate. This time it's the same x-coordinate, but the y-coordinate becomes negative of what it was. So in other words, if A is the object and it's got coordinates x and y, the image is going to have the coordinates x and negative y. So if I visually do this, I'm going to go 2 to the left in the image, but 3 down. So what are the coordinates of the image? It's going to be -2 and -3. And you can see this follows the rule that it's the same x but negative of the y. Okay, so same x coordinate, the negative y coordinate if I'm reflecting in the y-axis. Let's do a quick example here. Reflect the following figure in the given mirror line. So we're not doing a Cartesian plane one, we're just reflecting the following figure in the given mirror line. So what do I need to do? I need to be the same distance but in the opposite side of the mirror line. So I'll start with this part of the S in swag. It's going to be 1 away from the mirror line on the opposite side. This point, 1 away from the mirror line on the opposite side. This is 2 away from the mirror line on the opposite side. 2 away on the opposite side. 3 away. 3 away. So complete the lines. Looks like a Z, but that's a reflection of the S. Same here. 1 away, 1 away, 1 away, 1 away. 3 away, 3 away. That makes it easy to complete the W. So you don't need to do every single point on the diagram. You're just wasting time. Once you've done some establishing points, you can finish it off. So the bottom of the A, bottom of the A. The A is too tall, so it's going to be that tall. That tall. Bottom of the G, bottom of the G. So go across the G. Finish it off. So here I've reflected that figure in the mirror line. Okay, so that is reflection in a given mirror line. Hopefully that helps you out, and I'll see you in the next video.